students, welcome to Vidya Myriad. This video is made for class 10 on chapter number 13, surface areas and volumes, and today we are going to do exercise 13.3 from Ncert. Question number 1. A metallic sphere of radius 4.2 cm is melted and recast into the shape of a cylinder of radius 6 cm. Find the height of the cylinder. Now we are given the sphere radius 4.2 and radius of the cylinder is 6 centimeters. We need to find out the height of the cylinder, so let us assume it as h. We are told that it is in a form of a sphere which is melted to make a cylinder. So what we are going to do here is, we will find the volume of the sphere. The volume of the sphere will be equal to the volume of the cylinder. So that is 4 upon 3 pi r cube will be equal to pi r square h. We have the information with us. We can find out height by using it where pi gets cancelled. On solving, we reach to height as 2.74. Question number 2. Metallic spheres of radius 6 cm, 8 cm and 10 cm respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Let's find out the volume. When radius is 6 cm, its volume will be 4 upon 3 into pi into 6 cube. When radius is 8 cm, its volume will be 4 upon 3 into pi into 8 cube. And when radius is 10 cm, its volume will be 4 upon 3 into pi into 10 cube. Now this all will be resulting into a sphere. Let its radius be r. So volume of the resulting sphere will be equal to volume of all the three spheres which we have found out. So 4 upon 3 into pi into r cube, which will be a new radius after that, is equal to all the volumes 4 upon 3 into pi into 6 cube, 4 upon 3 pi into 8 cube, 4 upon 3 pi into 10 cube. 4 upon 3 and pi can be taken outside and inside left it 6 cube plus 8 cube and 10 cube. 4 upon 3 and pi gets cancelled. R cube comes out to be as 6 cube plus 8 cube plus 10 cube. So r cube is 1728. So r or radius of a sphere comes out to be 12 centimeters. Next, a 20-meter deep well with diameter 7 meter is dug, and the earth from digging is evenly spread out to form a platform 22 meters by 14 meters. Find the height of the platform. Now we are given the shape which is a well. It is in a form of a cylinder. So diameter is 7 meters. So radius becomes 7 upon 2. Depth or height is 20 meters. Height of the platform we have to find out. So let it be as h. So according to the question, we are told that volume of the earth will be dug out will be equal to the volume of the cylinder. So that means volume of the soil from well, which is in a cylinder form, will be equal to the volume of the soil which is used to make the platform. So if we take the volume of a cylinder, it will be pi r square h, which will be equal to make the platform. For a platform, we have length into breadth and into height of the platform, which we have to find out. Now length and breadth is already given to us as 22 by 14. Using that, we will find out the height. So volume of the soil which is in a cylinder, which we have taken out, that is pi r square h, that is 22 by 7 into 7 by 2 into 7 by 2 into 20 will be equal to 22 into 14 into h. So solve this, you will get h or the height of the platform as 2.5 meters. A well of diameter 3 meter is dug 14 meters deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meters to form an embankment. Find the height of the embankment. Now here, if we look at the figure, you are given the depth or the height, we can take it as 14 meters. Diameter of the circular end is given to us as 3 meters. Inner radius is given will be 3 by 2. So outer radius will be 4 plus 3 by 2. That is according to the shape also you can come to know. Width of the embankment is given to us as 4 meters. We need to find out the height of the embankment. Let it be h2. So according to the question, volume of the soil dug from the well will be equal to the volume of the earth used to form the embankment. Now when we are finding the volume of the earth for finding the embankment, there are two radius, outer radius and inner radius. So we need to subtract it. So according to the question, it will become pi r square h will be equal to pi into radius 2 or the outer radius square minus the inner radius square into h2. That will be the height of the embankment. We have the information with us for us that pi into radius is 3 upon 2 square into 14 is equal to pi into, so r square will be 11 by 2 and r1 is 3 by 2 according to this. We will use its square and find out the height. Pi gets cancelled. h2 on solving we come to know as 1.125, that is the height of the embankment by applying the formula. A container shaped like a right circular cylinder having diameter 12 centimeters and height 15 centimeters is full of ice cream. The ice cream is to be filled into cones of height 12 centimeters and diameter 6 centimeters having a spherical shape on the top. Find the number of such cones which can be filled with ice cream. Now to finding the number of cones, we need to find out the volume of the cylinder and the volume of the ice cream cone. So for a cylindrical part, let's find out the volume. Radius is given to us as 12 by 2, that is 6 centimeters, and height is 15. So volume of cylinder is pi r square h, so that is pi into 6 square into 15, which is 540 pi. Let's find out for the ice cone part, that radius is given to us as 6 by 2, that is 3, height will be 12, and the hemispherical part will be radius 6 upon 2, that is 3 centimeters. Now in order to find out the volume of the ice cream cone, it is the volume of the conical part as well as the whole volume of the hemispherical part. So volume of the conical part is 1 upon 3 pi r square h plus, for the hemispherical part it is 2 upon 3 pi r cube. So just solve this and let pi remain as pi. It will come as total volume of the ice cream cone as 54 pi. Now we know the number of cones. We can find out volume of the cylinder divided by volume of ice cream cone. So that is 540 pi upon 54 pi. Here now look, pi gets cancelled. That is why I have not done pi calculations earlier. I left it as it is. So the number of cones comes out to be 10. How many silver coins 1.75 centimeters in diameter and of thickness 2 mm must be melted to form a cuboid of dimension 5.5 into 10 into 3.5 centimeters? Now coins are cylindrical in shape. Height of the cylinder is 2 mm, which is 0.2 centimeters. Now be careful, here the units are not same. We have to make it same. So here I am making it all as centimeters. Now radius of the circular end is 1.75 divided by 2, which comes out to be 0.875 centimeters. Now we are told that number of coins which will be melted to form the required cuboids. So how many coins need to be melted? So let it be n. So n into, what is the formula of a cuboid? A cylinder, pi r square h, which will be equal to the volume of the cuboids, that is L into B into H, which is given to us the measurement 5.5 into 10 into 3.5. Now if you are finding this as a confusing that we are calculating n coins, you can even divide it afterwards also. First find the coins, volume of the coins, find the volume of the cuboids, and you can divide it to find out the number of coins that are used. It is your choice, you can do it like that also. So we can just put the values here and we will come to know that n comes out to be 400. Next, a cylindrical bucket 32 centimeters high and with radius of base 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeters, find the radius and the slant height of the heap. Now it is very clear with the help of the figure. You have a cylindrical bucket whose measurements are with us. Now this has been emptied and there is a conical heap that is formed whose height is given to us as 24. Now we need to find out the radius and the slant height of the heap. For that we are already given the cylindrical part bucket height is 32 centimeters, radius is 18 and height of the conical heap is 24. Now the volume of the sand in the cylindrical bucket will be equal to the volume of the sand in the conical heap. It is quite clear from that because we are emptying that bucket to make that heap. So what does it mean? According to the question, volume of the sand, it is in a cylindrical form, so pi r square h is equal to volume of the conical heap, that is 1 upon 3 pi r square h. So since the height we have taken h1 for the cylindrical and for the height of the cone we have taken as h2 since they are different. So pi into, for the cylindrical radius is 18 into 18, height is 32 is equal to 1 upon 3 into pi into r square. We have to find out the radius into 24. So on solving this, pi gets cancelled. So r square comes out to be 36 into 36. What does it mean? Radius is 36 centimeters. Now for the cone, we have the height with us, we have the radius with us. We can find out the slant height easily by using the formula of square root of r square plus h square. R we have come to know 36 square, height is 24 square. So 1296 plus 576 square root of 1872, that comes out to be 12 square root of 13 centimeters, which will be the slant height of the cone or the heap formed. Next, water in a canal 6 meters wide and 1.5 meters deep is flowing with a speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeters of standing water is needed? Now here we have a canal which is in a shape of a cuboid. Dimensions are given to us, breadth is 6 meters and height is 1.5 meters. Now we are also told that speed of the canal is 10 kilometers per hour. So what does it mean? In 1 hour it is covering 10 kilometers. So in 60 minutes also it is covering 10 kilometers if we convert hour into minutes. So we can find out for 1 minute it will be 1 upon 60 into 10 kilometers. We need to find out in 30 minutes. So in 30 minutes it will be 30 upon 60 into 10, which comes out to be 5 kilometers, which is 5000 meters. Now according to the question, volume of the water in the canal will be equal to the volume of the area irrigated. So volume of the canal will be in a form of L into B into H, which will be equal to area irrigated multiplied by height. Height is given to us as 8 centimeters. So 8 centimeters will be converted into meters by dividing it by 100. So we have the information with us. 5000 into 6 into 1.5 will be equal to area irrigated into 8 upon 100 meters. Using this we can find out area irrigated as 562500 meters square. So since it should be in hectares, we will be dividing it by 10,000. It comes out to be 56.25 hectares. Next, a farmer connects a pipe of internal diameter 20 cm from a canal into a cylindrical tank in her field, which is 10 meters in diameter and 2 meters deep. If water flows through the pipe at a rate of 3 km per hour, in how much time will the tank be filled? Now, for cylindrical tank, diameter is 10 meters, so radius is 5 meters, depth given to us is 2 meters. We can find out its volume, that is pi r square h, which comes out to be 50 pi meters cube. This is according to this cylindrical tank. Now rate of flow of water is given to us is 3 kilometers per hour. We need to calculate in minutes, meters per minute. So it will be 3 into 1000 upon 60, which comes out to be 50 meters per minute. So now according to the pipe dimensions, we are given internal diameters 20 centimeters. So radius will be 10 centimeters. Since it is in centimeters, we need to convert it into meters, which will be 0.1 meters. Now volume of the water that flow per minute will be again pi r square h. So pi into 0.1 square into 50, that comes out to be 0.5 pi meter cube. So therefore the required time will be 50 pi upon 0.5 pi. Pi gets cancelled. It comes out to be 100 minutes. That's all for this exercise, children. It was quite simple. Just understand what is given to you and it is converted into which shape. So two shapes are basically there, and for understanding that, it is very clear that volumes of both will be same. Using the volume formula, you can find out what is required in the question. If still you have doubt in any of the parts, you can mention in the comment section or you can also email me. Thank you so much, children, for watching the video till the end. Very soon I am going to come with the next. Till then, see you children. Goodbye. Take care.